MARIN was founded in 1932, and in the last century we have tested more than 10,000 ships. But we used to test them all one by one at a time. In the last couple of years we got more and more the question, can't you test big assemblies of a lot of models at the same time? For instance, like floating bridges, floating islands, and like today, offshore floating solar.
We're testing 54 interconnected offshore floating solar platforms, representing a real-world capacity of around 6 megawatt peak of solar power. This marks our third campaign at the MARIN Offshore Basin. SolarDuck began here 2 years ago with a single triangular platform, followed by 6 in a Hex 1 layout last January, and now 54 in a Hex 3 configuration.
So when you start testing so many models at the same time, you can't rely on your old measurement techniques. Therefore, we have worked on this new optical measurement system in which we can track the motions of all these platforms individually. And we do that by placing these optical markers on every platform and by tracking the markers with 16 cameras mounted here on the ceiling. Throughout the industry, there are basically two major questions regarding these kind of assembles. One question is the wave shielding inside such an assembly. Second major question is, what are the forces in between all those platforms? With our unique measurement system, we can measure the compression in all the hundreds of springs you see here.
Scaling our full-scale design to a 1 in 20 model came with certain challenges, but using carbon tubes and lightweight connectors, we successfully matched the correct scale factors while closely replicating mechanical behavior. This test focused on the dynamic response of a multi-body system, including coupling and mooring loads and the shielding effects of current, wind and waves.
We can cover a measurement area of 15 by 15 meters and in that track the motions of dozens and dozens of models at the same time. And by that, we are one of the first able to facilitate these kind of tests on this scale.
Across all tests, we've observed that wind has a notable damping effect. First on single platforms and even more clearly across full 54 platform arrays. As wind passes across the plant, platform motions visibly decreases. It's great to see our expectations confirmed.
We're proud to collaborate with MARIN and use their state-of-the-art motion tracking to conduct this research, a major step forward towards large-scale offshore floating solar.